A human mission to Mars has been a long-cherished objective of space scientists, and several proposals for manned mission to the Red Planet have been made since 2010, but none have taken off successfully. However, NASA has been working to cross the hurdles that such a mission is likely to throw up. Isolating a group of scientists in a dome in Hawaii to simulate life on Mars for 8 months was one of the many tests that the organization has been conducting to make sure that a mission to Mars becomes a reality in the future. Another major concern of sending humans to Mars is the effect of space radiation on the astronauts of such a mission. These charged particles may be small and unseen, but they can be fatal. And space is full of these particles. To get around this problem, NASA's Human Research Program (HRP) has been trying to understand the effects of radiation on the human body and how to reduce it. According to the team, people often mistake radiation on Earth to be the same as space radiation. This is far from true, as we are protected by the cozy blanket of our atmosphere that keeps out most of the sun's harmful radiations. However, in space it's a whole different ballgame altogether. Radiations from the sun and cosmic radiations are forever hurtling through the vacuum of space. Cosmic rays are emanated by a dying supernova. When this happens, the surrounding space is blasted with radiation. The effect of the galactic cosmic rays (GCR) on the human body has to be studied in depth to effectively counter it. According to NASA research physicist John Norbury, GCRs that come from exploding stars known as supernovae outside the solar system are the most harmful to the human body. Solar events like flares and solar storms often release a huge wave of photons and radiation into the space around the sun. Other sources of radiation include the Van Allen belts, where radiation particles are trapped around the Earth. One of our biggest challenges on a mission to Mars is protecting astronauts from radiation, said NASA space radiation element scientist Lisa Simonson, Ph.D. said in a video released by NASA. "You cannot see or feel getting bombarded by radiation," she added. Space radiation is particulate matter and consists of all the elements of the periodic table. In space, there is particle radiation, which is basically everything on the periodic table. Hydrogen all the way up through nickel and uranium, moving near the speed of light, said NASA research physicist Tony Slaba. This kind of radiation is much more dangerous than radiation on Earth because they collide with the nuclei of the materials they touch and cause a breakup leading to a secondary radiation, and can be usually volatile in nature. This precludes NASA from using heavy materials like lead to shield the spacecraft, and in spacesuits as the incoming space radiation will collide with the shielding lead to trigger secondary radiations. The exposure is worse than normal radiation, and in the long run can prove fatal, Slaba added. The HRP is hence focusing its efforts on countering the harmful effects of space radiation by using various liquid or gaseous shield materials for the astronauts inside the spacecraft. NASA Space Radiation Laboratory (NSRL) is facilitating the researchers in investigating ionizing radiation and the effects it has on the human body. However, it is no easy task, as it is difficult to simulate the long-term exposure to radiation that astronauts may face in space, and the improbability of recreating the harsh radiation of space in a laboratory setting.